To solve this, the only game in town is to factor. So we look at this, we see it's cubic, but it's not one of those like simple like x cubed plus 27 type things, or x cubed minus 64. So that's kind of tricky. So now I gotta look at each term and just notice that there is a common factor among the three terms of x. I'm going to pull that GCF out and then recognize that if I want to get an x cubed back, this should be x squared. If I want to get 4x squared back, and I've got the x out here, I need a 4x. And then if I want to get negative 21x, and I have an x out here, I need a negative 21. Then this is going to factor further, and this is kind of our old-timey stuff of trying to find things that multiply to make x squared, trying to find things that multiply to make the last term negative 21, and the inner and the outer term should combine to make that middle. So to get the x squared, of course, I have one thing I could choose, x and x. And for 21, the sign is a negative, so the signs will be opposite. And the first thing comes to my mind is 3 and 7. And I know they're going to have opposite signs because it needs to make a negative 21. And I want them to combine to make a positive 4. So this should be positive, this should be negative. So really the first part of this is just factoring, which we've been practicing. Now that this thing is factored out, since it's an actual equation, it's supposed to equal 0, we're going to take each factor and set each factor to 0 and solve. So this x is already isolated, that's done. X equals 0 is one answer. To get this x by itself, I would add 3 to both sides, giving me x equals 3. And then to get this x by itself, I'd add 7 to both sides, giving me x equals 7. So the solution to the equation up here is 3 solutions, 0, 3, and 7. And if you have any doubts, you can plug in 0, 0, 0, you get 0. If you plug in 3, 3, and 3, you'll get 0. Plug in 7, 7, 7, you get 0.